Okay, so you're going to learn about position versus time graphs. And before we even start this, I want you to, first of all, don't get too fixated on the math. Whether you get the right answer or not, whether the simulation claps its hands for you or whatever, don't focus on that so much. What's more important is that you can identify the shapes and understand the signs rather than the actual values. But okay, that said, our task for this activity is to look at a bunch of position versus time graphs and then find the velocity. Remember what velocity is? It's speed with direction. So the direction in this case will either be a positive or a negative. And this is going to be an object that's not going to be moving at a constant speed the entire time. It's actually going to change speed and it possibly will change direction on you. So when you're looking at position versus time graphs, really think about what you would have to do to walk one of these out. Mentally walk a graph like this out. So if I'm looking at this graph, I first of all know in the brown section, notice what's going on. At time 0, when I first start walking, I start out at position around 220, 225, something like that. And I wind up at position, and again, this is good practice in helping you read graphs. I wind up finishing at position around 680. And notice that this is a line. Okay, it's not a curve, it's a straight line. And I could actually come up with the slope. And hopefully you've been learning in this module that the slope of a position versus time graph gives you the velocity, average velocity. So what I have to do here is I have to calculate my slope. Again, for me right now, it's sufficient to just understand, oh, this object must be moving at a constant velocity and that velocity must be positive. Why do I know that? Because I've got a line here that has a positive slope. And since slope is average velocity and my slope doesn't change, it's not a curve or anything, it's a constant level, a constant amount of slope. So therefore I know my object is moving at a constant positive velocity. I could actually find out the value by subtracting my final position, my ending position, at least for this segment, is around 680. And a piece of scratch paper would come in handy for this. And my starting position is 220. And so I know the difference in position, which is also called displacement, is about 460 or so. And then I need to know how much time it took me. Well, gosh, I started at time 0 and I wind up out here at time 34. And so a little calculator does not come in handy, does not hurt to have handy. And so if I do the math here, my average velocity here for this segment should be about 13.5 meters. Notice that my units on the y-axis are meters, so my displacement is in meters. And my time, so if my rise of this line is in meters, my run of this line is in seconds. So I get meters per second, and I get 13.5. We'll see if that actually is the correct value. Again, I may have read my numbers wrong. Yes, I'm not going to sweat that too much. Now notice the green section. What can we infer about the green section? In the green section, my object is not changing its position, is it? It's at position 680, and it stays at position 680. And gosh, how many seconds elapse? Like 12 seconds elapse, and I haven't moved a bit. So therefore, what's my average velocity during that time period? It's 0, right? Well, how do I know that? I could say, well, gosh, 680 minus 680 as my displacement is 0, but I can just look at the graph and notice, oh, that's a horizontal line. A horizontal line has a slope that is 0. Since I know a slope on a position versus time graph is average velocity, since my slope is 0, my average velocity is 0. So I know there my object is stationary. Now what do I know in the blue section? Well, gosh, I know that I've got a negative velocity. Why? A negative constant velocity. Why do I know that? Because I've got a straight line that slopes downward from left to right. It's got a negative slope to it. Since slope is average velocity, I know I've got a negative velocity. Can we calculate it? Sure. Find my endpoint. I wind up at, it's around position 40 or so. And then I subtract my initial position, which in this case is 680. Just remember, I'm just focusing on this segment. So I wind up with 40 minus 680. That winds up being a displacement of negative 640. And the negative is important there. Remember, displacement can be negative, velocity can be negative. That indicates the direction you're moving. And then my time. Well, gosh, I started here about 46 seconds, and I wind up at 80 seconds. So 80 minus 46, that's an elapsed time of 34. So I wind up with my displacement, negative 640, divided by my time, which was 34, and I wind up with negative 18.8. Okay. Now I'm gonna punch these numbers in and see if it agrees with the calculator here. So let's try it. So I can put in my name, and remember it asks you the different segments. So my first segment was 13.5, and it's understood to be in meters per second, so I don't think I have to enter the units there. My middle section, that's when we were stationary, was 0. And then here, for the last section, remember my velocity was negative, and that is very important to make sure you put the negative in there. Negative 18.8. We'll see if I'm right. And how do we do? Actual speed was 12.7, 0, negative 18.9. Our answers were good. We were close enough to what the computer had different values for the starting and end points, perhaps, but we did pretty well there. So do yours in a similar manner.